My name is Kwesi Rutledge. I'm a METEOR postdoctoral fellow here at CSAIL, where I work with professors Chu Fan and Nicholas Roy on topics related to safety-critical control of robots, whether they be robotic arms or ground vehicles. When we're dealing with robots in an uncertain world, I'm really interested in how you plan robot actions so that you can both learn more about the world while also guaranteeing something about safety or eventually achieving the task in front of you. So one of the research projects that I have in mind that I'm currently getting off the ground, I call it the space claw, which is what it sounds like, a claw that's put into space to grab bits of space junk. Space junk is actually a really important problem. Recently, I think within the past month, the International Space Station had to move out of the way of some space junk that was barreling towards it. There's a really big interest in designing some type of system that can collect this junk and maybe bring it to Earth or burn it up in some way. And this problem actually uses a lot of the things that I really like about reasoning about an uncertain world. So you need to somehow be able to guarantee you can grasp these unknown objects, which might have unknown geometries, unknown centers of mass. And so one of the first projects that I'll be dealing with here is using a smaller scale robot arm to basically determine the center of mass of an object that it's pushing, and then push that towards a goal, again, with like little a priori knowledge of the shape and the geometry of that object. Here we are in Building 31. This is one of the lab spaces of the Realm Laboratory. Specifically, this is our main space where we fly drones like this one. Around the space, we have many drones here, and we're studying how multiple agents or robots, when they're in the same space, can interact with each other and communicate. What I would like to do in this space next is that we will bring a robot arm in here, not to play with the drones, unfortunately, but to again study how robot arms interact with the world. And essentially design adaptive controllers, adaptive algorithms that can do things like infer the mass of an object or the moment of inertia of an object in order to safely move that object to where you want it to be. I've been learning a lot from the two groups that I'm a part of. Thankfully, METEOR was able to pair me with two excellent mentors who I think have these complementary skill sets of low-level and high-level planning for achieving robot arm tasks. One of the necessary things that we do in robotics is that we break down or separate problems, usually into, we'll say, different abstraction levels. So typically, in the lab where we work right now, we define our problems in the realm of actuator commands. So what is the signal that you need to give to your motors to make this drone fly at this exact height? Now, this is very good and very challenging in its own right, but humans often don't think at this level. Humans often tell you tasks like, I want you to go into this room and give me this bottle of water, for example. So there's a separate, not necessarily separate, but related area of robotics that studies more of these high-level goals where your goals aren't written in terms of actuator commands and other technical quantities, but your task is more in terms of objects in the world, maybe concepts, so maybe how you organize objects in the world, and then you plan over this, what we call abstract space. Now, these two worlds frequently don't connect enough, I think, in my opinion. And so my work really is trying to connect these two worlds of low-level, actuator-level planning with high-level conceptual planning to achieve these nice adaptive tasks that we want our arms to accomplish. One of the things I'm looking forward to is leading or managing projects, robotics projects. As a PhD student, I didn't get as much experience leading kind of larger teams of roboticists answering interesting questions. And I'm really excited to learn that skill set and hopefully bring that to a career as a PI or maybe a person in industry or startup owner or something like this.